If you ever wondered what like $8,000 looks like in raw form right there. Anyway, this is a Lightning Z card. This card was actually sent to me by Splave. You can probably see them on the leaderboards. I'm getting back into XOC. With that, there's some utilities that we use. There's a new utility kind of making the rounds, and we're going to talk about today whether or not it's better than MSI Afterburner. We know it does more than MSI Afterburner, a lot more. The question is it safe? Should you use it? And you're probably not going to listen to me anyway on whether or not you should or you shouldn't. So we'll talk about the settings, the sliders, what they do, what they mean, but not with this today. I still have some more things I got to manufacture for this. My mill's been running non-stop for days making stuff for this. Yeah, we have a bit graveyard, I know. That's okay though. I got huge upgrades coming for the Makara in a separate video where I'm going from an 1/8 inch shaft to a 1/4 inch shaft. And 3D probe, girthy probe shafting.
Today's video is sponsored by Gamdias and the new Thor P2 series power supplies. Available at 850, 1050, and 1350 watts, the Thor P2 is built for everything from high-end gaming PCs to seriously powerful workstations. It's fully modular, 80+ platinum rated, and ready for ATX 3.1 and PCIe Gen 5.1 with a native 12-volt 2x6 cable for the latest high-powered graphics cards. Inside, you're getting all Japanese capacitors, an LLC resonant and DC to DC design, plus a 135mm fluid dynamic bearing fan that automatically adjusts its speed based on temperature to keep things cool and quiet. You also get support for C6 and C7 power states, and a full suite of electrical protections, and best of all, Gamdias backs the Thor P2 series with an industry-leading 12-year warranty. So if you're building a system that needs serious, reliable power, check out the Gamdias Thor P2 series power supplies.
So the software we're going to talk about today is specifically mVolt Plus, but I want to say this real quick. This was actually tipped off to me by a viewer who emailed me showing me they actually got like an 800-point increased score, and I think it was Steel Nomad or Speedway, I think it was Speedway. 800 points in any like 4K score is a huge jump. But doing some research, we're not sure which came first, this or HYDRA. HYDRA is actually developed by a developer by the username of OneUSMUS. HYDRA's is hidden behind his Patreon paywall. So that's why we're using mVolt Plus, because it's free. Moving forward, the comparison today is between that and MSI Afterburner. Now, MSI Afterburner is very basic, it's very simple. We're also going to be using our very cheap 5090 Tough for this. I still have the scoop on there, I never took it off. Anyway, our 5090 Tough, you know, this is a regular old card, nothing special about it. Can't even say that with a straight face, honestly. Anyway, this is MSI Afterburner, this is the latest beta. I think this is the beta. No, 4.6.6. It's not the beta. I think 4.6.7, I believe, is the beta. Same overall functionality, but it's very basic. Other than the telemetry, which you can monitor here, not worried about that right now. The sliders you get is core voltage, which is just a percentage slider, and that's only open if you hit the settings and then you check all of the unlock voltage control stuff, and you get these different, you know, third-party extended MSI, standard reference design, whatever. I just leave it standard MSI. So all that does is allow it to reach peak voltage sooner in the frequency curve. So you have to understand the VF curve, or the voltage frequency curve, that says at this voltage, this frequency is all it's allowed, because if you have less voltage and a higher frequency, crashing happens, right? Voltage and frequency go hand in hand. The third part of that is temperature, which also says if the temperature is lower, then frequency go higher, voltage go higher. So that's the other equation there. So typically what we'll do is, obviously for doing any sort of overclocking, we are going to max out the fan curve or just go 100%. And it's probably gonna get loud now, I apologize. We also are gonna max out our voltage slider because we want the voltage to hit sooner. Believe it or not, NVIDIA cards are not like AMD cards, where undervolting will not always get you a better result. Usually you need more voltage. And the reason why we're maxing out the voltage is because voltage limitation or voltage limiting is voltage is usually the factor you hit first before you can go any farther in your overclocks and such. Voltage locks at a certain, usually it's like 1045, 1050 millivolts, and then you can't go any farther, you add more frequency, you crash because you don't have the voltage to support it. So that is why we max out the voltage curve. AMD is totally different. This utility is even designed for 50 series cards. You might be able to use it with 40 series, but it may look different. Core clock, that's just an offset to the voltage frequency curve. So when we say like, okay, if I go 200, that means let's add 200 megahertz to wherever it lands on that VF curve. So it's not adding 200 over base, it's adding 200 over the boost clock of the voltage curve. So keep that in mind. And the memory clock, pretty much on all GDDR7, you can just max that out. So I have found that so far in MSI Afterburner, I can get about 360 offset with this card reliably. And what we're gonna do real quick is we're just gonna run Speedway. I'll use Speedway as an example, like, and whether or not we can get better scores with mVolt Plus. mVolt Plus is fun for anyone that likes to tweak and play around with settings because you get access to pretty much all of them. MSI Afterburner only gives you access to some very high level stuff. There's obviously crossbar clock. Think of crossbar as like infinity fabric for AMD CPUs. You have to have an interconnect for all of these different things that are on the GPU core. The GPU is also not just a single die. I mean, it kind of is, but there's different aspects of that die that are controlled by different voltage rails, and they have to communicate between the memory controller, the GPU controller, and other SMDs and stuff that are on the board. So think about the crossbar as the frequency on all of those things talking to each other. They have different voltage curves for 3 different parts of the board, not just memory, not just core, but even the crossbar voltage, which is part of, I believe it's MSVVD. So there's a lot of things that you're gonna have access to with mVolt that are going to be a little overwhelming, and that's the point of today's video, is to sort of explain them. So I'm just gonna go ahead and do one Speedway run, and we're gonna see what our score is. Now, technically, I should do like an average of 3, but Speedway tends to be pretty consistent, where I might see maybe 50 points to 100 points difference per run. Anything I see in that plus or minus is considered within normal margin run-to-run variance. But if I see like an 800 point score difference or 500 plus, I know something happened that increased that score. 15400, cool. Anyway, okay. So I know I could go plus 360 here, 100 plus or 100% voltage curve. That means just bring the voltage on sooner. 3000 on the frequency and 100% fan. So I'm gonna reset that. I'm gonna make sure Afterburner shut down. We don't want that interfering. And I'm gonna run mVolt. mVolt's cool. It's not actually a program that gets installed. It runs as its own executable. So it also could potentially impact performance, but that's okay. That's one of the things we're gonna check. This is where people are gonna be immediately like, I'm a little overwhelmed. There's a lot of stuff going on here. First and foremost, here's the boost button, pins the GPU clock at its maximum boost clock. Telemetry just opens up the telemetry, but this is where I said you can see the current frequency. So we got core clock, we got memory clock, crossbar clock, system clock, video clock, unknown, okay? Then you can see the actual voltage of the rails right here. So we've got the different voltages, like I've said, so you have here the NVDD core voltage. You've got the MSVDD voltage range. So this would be like the, like I said, crossbar would be here. MSVDD would also be like the video clock. So this would be like the NVEC encoder and such. You got your power limit. Now, power limit's still gonna be determined by the card's VBIOS. You can't go beyond that. There's discussion that HYDRA apparently will allow you to go beyond that, whatever is in the VBIOS. Now, the VBIOS of all 5090s is, with the exception of the FE, 100, that's where it is. That means 100% of 600 watts is all you get. The 5090 FE, however, goes down to like 575 out of the box, and you get like an additional 4% out of it to push it to the 600 watts. The custom cards like the Lightning Z, like this guy right here, the Matrix, the new 20th ROG card from Asus, those cards go well beyond 600. Enable XOC voltage range up to 1.20 volts. So what I want to do first is I want to see, okay, so right now it's allowing me to have 1150 millivolts to the card because that's what the card's VBIOS is allowing. So if I do this real quick, and I know how much Steve loves heaven, so that's why we're gonna go ahead and use this. So we are currently at 1068.75 millivolts. Oh look, I have 1095 set. Now the reason why it's not going to 1095 is because it's saying the frequency that we're currently at, which is 2917, is only requesting 1068 millivolts. So that's how you should look at that when you read this. But you're gonna notice there's a lot more rails sitting here, right? But I can say, let's allow MSVDD to go up also to 1095 if I wanted, boom. So you can see right now, it went to 1075. If I default that back, it's 1035. So this could help us with some crossbar stability when we start to push the clocks really fast. The one thing this doesn't show me, which I really don't like, is it doesn't show me temperature anywhere, which I think is really dumb. Like, it doesn't show temperature on any of the monitoring stuff. So that's, to me, dumb. So I'm now going to max out. Sure, why not? I'm now, MSVDD is not important, power limit, voltage, fan control, video clock offset. I'm not gonna touch any of the clock offsets for the crossbar or anything. So all I've done now is allow it to go up to 1150 volts. So we just had a driver crash. This is gonna happen because what could have potentially happened here is it could have gotten, with that higher voltage, could have requested a frequency that's not stable, because we never actually, even at 360 offset, it never tried to go to that frequency because the voltage stopped it. But the other thing we're gonna have to try here also is going to be crossbar, because I want to see by getting the crossbar faster what that will do to our score. What I'm gonna do now is I'm going to enable an XBAR offset of, I don't know, 250. I'm just guessing here, I have no idea. Not gonna touch system clock, not gonna touch video clock. I have a sneaky suspicion getting the clock bar frequency higher is gonna give us big improvement, similar to how Infinity Fabric Clock works on AMD CPUs, specifically with like RAM and stuff, because doing my research on how the scores progressed more than 1,500 points or almost 2,000 points beyond where I was when I was number 4, and now I'm down to like number 30 or something like that. Newer custom BIOS that were specifically boosting the crossbar or the XBAR clock. So I have a feeling this might do something. And if not, then I just don't know. It could be cooling in this aspect for me. You know, we might just be maxed out on the, yeah, see? Okay. All right, I think it's time to end this one. I just wanted you guys to understand what the different things are. Whether or not it means anything to you in your graphics card boils down to one main variable, the silicon lottery. Sometimes you'll win, sometimes you'll lose, and it's just, you never know what's gonna happen in between. But it'd be very difficult for you to damage your card using this, as long as you keep cooling under check, or in check. But whether or not it's useful to you, I mean, for most people, no. It's just, Afterburner, there's a couple things that I feel like Afterburner is great for, and what 99% of people would be using it for. Max out your power limit, custom fan profile, you know, you can save profiles to it, and then maybe a little bit of an overclock. That's it. That's really all I need to do. For most people, just bump your fan curve up. It keeps the card colder, it keeps the clocks higher. That's all most people need to do. So, all right, guys, thanks for watching today's video, and make sure you stay tuned for this guy when we get around to it. I got some more heat sinks I gotta make and fan brackets and all that stuff, but I'm trying to come back with a vengeance.